welcome to Byju's IAS. Earth, as our home planet, has always puzzled humankind quite significantly. So, for a very long period of time, people have been wondering what the Earth looks like. There was this theory which went on for a very long period of time, which postulated that Earth was actually a flat land. It was not round. So, since time immemorial, there has been a lot of amusement, there has been a lot of questions which have been raised about it. That what does it look like? What is it formed or composed of? And how is it that this wonderful planet came into existence? Now, various different geographers and geologists have been propounding various different theories for time immemorial now. Now, even though we have not transversed through the center of the Earth because it is humanly impossible to do so, but by now we have decent enough idea about what this planet is made up of. What constitutes this large blue planet that we call home. And also, now we know that how is it that this planet came into existence. So in this video, we shall be talking about the interior of the Earth. We shall be starting with understanding the formation of the Earth. How is it that this planet came into existence? How is it that this planet evolved into its current state? And also, what are the various different layers when we talk about the planet? What are their physical states when you talk about the crust, the mantle, the core, and what are their individual properties? So without further ado, let us take a look into the interior of the Earth and let us further understand that what this interior is actually composed of. But before that, one thing that we have to understand, that Earth is a large spherical object with a very large radius. The radius of the planet is close to around 6370 kilometers. But then, Earth as a planet is not a perfect sphere. It is what is referred to as a geoid. Now, the shape of this planet, when we say that it is not a perfect sphere, it is a geoid, what do we mean by that? So, the planet is actually slightly flatter near the poles and slightly elongated near the equatorial region. So, if you have to draw the rough map or the rough representation, it will appear to be like a flattened sphere out there. A sphere which has been flattened from top and bottom. So this is the actual shape of this planet. Around the equatorial region, you have a slight bulge in the radius which is generally observed. Now, when we talk about this planet, first of all, we have to understand that the knowledge about the interior is mainly based upon inferences as well as the various estimates. And why is that so? Because think about it. Going deeper into the interior of the planet, that is as deep as 6400 kilometers, that is what it will take to reach the center of the Earth. And that is simply humanly impossible, because if you look at it, as you start moving deeper inside the Earth, the temperature starts to rise quite rapidly. This rise in temperature, as you start moving deeper inside the surface, is what is also referred to as geothermal gradient of the planet. So what is this geothermal gradient in a nutshell? So geothermal gradient is basically the change in temperature which is observed as we start moving into the depths. Now, why is it that you have an increasing temperature as you start moving inside? So there are multiple reasons for the same. Few of the reasons are that you have quite a significant amount of residual heat which is left in the interior. Now, what do we mean by residual heat? All those factors we shall look upon in the following part as we move on to understand the different layers, and we will then understand and will have a better idea that why the temperature changes so much and where is it that the temperature increases quite rapidly and suddenly. Now, the information regarding the interior of the planet is obviously ascribed to few of the sources that we have. Because obviously, as I have already reiterated, we cannot go into the depths to the core. Now, there are multiple sources which can be divided into two broader categories. You have the category as the direct sources, which give us information about what the interior is composed of. And then we have the category of indirect sources. A combination of direct and indirect sources, they help us understand the composition of the interior. So let us take a look into each one of them and let us try to understand what do we mean by these direct and indirect sources. So the name in itself, that is direct sources, an idea that this gives you a first-hand information. So direct sources are of two types. The first source of information is basically ascribed out of volcanic eruptions. Now, whenever there is a volcanic eruption which occurs, that means what? Molten materials from inside the Earth's surface that rises up and that flows out as lava. Now, this lava eventually does solidify to form various different types of rocks. But by studying this lava, the chemical composition, we get an idea about the depth from which this lava has come up. We also get an idea about the mineral composition, the mineral distribution that you end up finding in the lower levels of the planet. So every time that a volcano erupts, our knowledge and our information about the planet, that suddenly and significantly does increase. It also helps us understand about the presence of solid and liquid materials and the distribution of the same in the interior, but at the same time, the gradient of temperature, especially in those areas, that is the upper portion from where this molten magma is supplied, the upper portion of the mantle and the crust, we get an idea about how the temperature is increasing in those regions. Then the second direct source by which we get an information is basically mining and drilling activities. But here again, our action and our source of information is quite limited because we cannot go deeper into the Earth's surface beyond a particular limit. But here again, our source of information and the amount of information that we can gather out of it is quite limited. Because to think about it, we cannot dig beyond a particular depth. The deepest drilling that you see out there is actually present in the Kola Peninsula in the northern part of Eurasia. And this is the deepest drilling which extends up till around roughly 12 kilometers. But even at these depths, the temperature increases so significantly that it becomes almost unbearable. That is why this drilling was eventually abandoned. So, mining and drilling operations, they help us in two ways. First of all, they help us understand about the density of the rocks as you start moving into the depths. It also helps us understand that how the temperature and pressure, both of them, they keep on increasing. Because the rocks that you see on the surface, the large rocks, the mountains, the boulders, all of them might be seeming very mighty at the appearance. But as soon as you start going deeper, the rocks become much heavier and much more denser. So all those ideas we get from these direct sources. But then we have multiple indirect sources at our disposal again, which gives us some clue regarding what the interior might be composed of. So let us take a look at few of these indirect sources. Now, indirect sources mean what? That they directly don't tell us about the composition of the interior, but by inferring certain data pointers and by observing certain experimental results, we can infer what kind of materials might be present. We can reinforce our understanding by multiple experiments, and thereby we can reach a conclusion that yes, indeed, if iron is present in the core, then nickel is also present. So that is basically done with the help of experiments and inferences and various different scientific readings of parameters which are done on an everyday basis. So we have four distinct kind of indirect sources. The most important and the vital one is seismology. Now what is seismology? Seismology is basically the study of the seismic waves which are generated whenever an earthquake does occur. Now as we will look at it in the module of earthquakes in detail, that whenever an earthquake does occur, it actually ends up releasing significant amount of energy in the form of waves. Now these waves, they propagate in all different directions in the interior of the earth itself. And as these waves end up moving, their deviation, their diffraction and reflection within the different layers helps us understand what these layers are composed of. So just to give you a hint about it, and you will know about it in much further detail when you go and reach the chapter of earthquakes, but just to give you a brief introduction, Suppose this is the planet and an earthquake has struck at a depth of 60 kilometers. Now from here the energy waves that will be released, first of all they will hit the surface. But at the same time, these energy waves will travel throughout the interior. And by detecting these energy or seismic waves in different parts of the planet, we can get an idea about the regions through which these waves would have traveled by. So seismology is a very important source of information. It is this seismology which also helps us determine which layer of the planet is actually composed of a liquid layer, or which layer is very solid, which layer is semi-solid, because in each of these medium, the speed of these energy waves, they end up changing. These waves end up also getting reflected and refracted. Now, the next indirect source of information is gravity. Now, the gravitational pull is not the same throughout the planet. There are slight differences which can be observed around the region of the poles and around the region of the equator. While this helps us understand the shape of the planet in a better manner, it also helps us understand the thickness of various different layers. So gravity is also a very important indirect source, but not as important as seismology or study of the seismic waves. Then after that, we have another indirect source, and that is meteors, study of meteors. Now meteors are basically flying objects in the solar system which come and hit the surface of the planet. Now these meteors, when they enter the atmospheric region, the outer region or the outer layer of the meteor simply burns off because of very high temperature that it encounters due to friction. However, when it crashes on the surface, the inner portion of the meteor is conserved. Now, how is it that the study of these meteors helps us understand about the interior of the Earth? So here we have to understand that be it the meteors, be it the planets, be it the asteroids, even be it the sun, all of these objects have evolved and emerged from the same nebular cloud which was present in the universe. It was from the same cloud made up of dust particles and many small debris that you had various elements which were then composed of. So the meteor's internal structure gives us an idea about what the early solar system would have looked like and how the planet would have evolved, and also gives us an idea about the various different elements which are present in the solar system. After all, our planet does have endless amount of elemental presence. So all these elements, were they present since the time of its formation, or did these elements come into formation once the Earth started evolving? So that is again a basic parameter that we get to know of. And then after that, we have another indirect source of information, and that is the magnetic field. So Earth as a planet does extend a magnetic field around it. It has got a magnetic north pole, a magnetic south pole. Now this magnetic field is generated from the planet because of the presence of iron and nickel in the core of the Earth. Now this iron and nickel and their dominance and their movement, that is what generates a magnetic field. Now by study of this magnetic field, we get an idea about the concentration of iron and nickel. But sometimes this magnetic polarity of the planet keeps on changing. The magnetic north continues to shift from time to time from one region to another. In the year 2020, the magnetic north pole of the planet shifted from the region around Alaska to somewhere around Siberia. Now, what did we get to know about the interior of the Earth based upon the fact that the magnetic field shifted? That helped us understand that there must have been a concentration of iron and nickel in the core, in the interior, which would have shifted in its position, in its location. And that is why in the new location, wherever that blob of mass of iron and nickel would have been, that would have been the new magnetic north, and thereby you also have a corresponding magnetic south. So these direct and indirect sources, they have helped us over a period of time not only to understand what the Earth is composed of, but also how did this planet come into existence, and what are the properties of various different layers as we start moving into the depths from the surface. Now, all these are going to be important for your prelims examination, because in prelims you can expect a question regarding what is a direct source, what is an indirect source, and so on. Now, after this, let us first of all get our basics correct regarding the evolution of how is it that this planet came into existence. Now, the origin or the evolution of the Earth dates back somewhere 5 billion years, 4.5 to 5 billion years before present. That is estimated to be the age of the Earth. Now, at that point of time, the universe was very different. The solar system, in fact, was very different, to be more precise. Now, in our solar system, at the central point, we had the sun, and all around the sun, we had a revolving mass of dust particles. Endless billions and trillions of dust particles, they kept on moving around the sun under the influence of the gravitational pull of the sun. Now, all these particles, initially, they collided with each other. Now, as a result of these collisions, imagine two dust particles colliding with each other. Now, whenever there is a collision between two objects, immediately there is a rise in temperature. Now, as they started colliding with each other, they started forming a larger aggregate, but at the same time, the temperature started rising. Eventually, millions and billions and trillions of these particles, they started colliding, forming a larger mass. Now, here you have to understand, when you have a small dust particle, it will have a smaller gravitational pull of attraction. But imagine you have a small mass and a larger aggregate which is formed now. Now, obviously, its gravitational pull will also start increasing. So it will start attracting more dust particles to itself, and thereby further more collisions will happen. As more collisions will happen, the size continues to increase, and this will keep on attracting more particles, further increasing the number of collisions. So it is a kind of a continuous feedback cycle, a self-sustaining cycle, where each and every collision results in further more collisions taking place, but more importantly, the temperature starts rising quite rapidly. So this is what happened in the initial few millions of years. So Earth was formed around 4.5 billion years ago as a result of accretion of many smaller objects which were present in plenty in early universe and around our sun. Now here you have to understand this loop which sustained this kind of collision activity to take place. So every time there is a collision, it would increase the size of what? The aggregate that is generated as a result of these collisions. So multiple dust particles will collide, they will form a slightly larger gravel or a pebble-sized particle. That will collide with more particles, a larger particle is generated. So the size kept on getting increased. Now with the increase in size, the gravitational pull also ended up increasing. Now this gravitational pull, as it increased, meant what you had? It attracted more particles. And as it attracted more particles, thereby it led to more collision. And this continued, and heat was produced as a byproduct. Now this heat which was produced as a byproduct of these collisions, that was very important in terms of melting the materials which were present in that large mass. Now, because think of it, you have millions and billions and trillions of collisions, with each collision increasing the temperature. So the planet that we know right now, around 4.5 billion years back, it was nothing but a molten ball of mass which kept on moving around the sun. But then, after some time, the number of particles present in the region around Earth, that significantly emptied itself because of huge amount of collision. So obviously, once the particles are not present anymore in the path of the planet, there won't be any further collisions which will take place. So as the number of collisions decreased and reduced quite significantly, what that led to is immediate cooling off the planet. Now, when you had this planet in molten state, at that stage itself, you had various different elements, various different compounds, all of them were in molten state, in liquid form. Now, when you have a liquid, imagine you have a liquid and you have a mixture of liquids rather. Let's say you have water, you have honey, all of these are liquids, right? But some will be heavier than the other. Now, if you end up and manage to pour all of them in a jar, what will happen? The heavier liquid will settle at the bottom. So, same thing happened in the initial stages of the formation of the planet. The heaviest elements, which composed of the heaviest liquids, all of them, they settle at the bottom. Now, when you consider Earth as a planet here, what do you think will be the bottom? Will the bottom of the planet be somewhere here? No, the bottom of the planet will be the center. Because from any place that you go from, that will be the bottom. From any place, if you start digging up and you start digging up the surface and you start going down, where is it that you will reach? You will reach the center. Be it the North Pole, be it the South Pole, be it at the equator, anywhere, you just start digging and you will find that you will reach the center. So, in the molten state, the heaviest liquids or the heaviest elements, they settle down in the central region. Now, at that point of time, the heaviest elements present on the planet were basically iron and nickel. Now, this iron and nickel, they settle down in the center, and that is what led to the formation of coal. Even today, if you look at the core of the Earth, it is heavily composed of iron and nickel. So, if you look at it, it was during the molten stage that heavy materials like iron and nickel sunk to the center of the Earth. Gradually, the Earth started to cool down and lighter silicates and lighter materials which were floating on top, they started solidifying very gradually. Because the outermost materials, they were in contact with the outer space. So, being in contact with the outer space and outer atmosphere, the uppermost layer is the one which started solidifying immediately. Now, when they started solidifying, the interior portions were still very, very hot. It was only a thin layer on top, the crust, which started solidifying. The interior layers were still very hot. Now, as a result of that, what happened? Now, in the interior layers, you had various different compounds, various different elements present in the form of their oxides, hydroxides, etc. So, automatically, when these will be present in the molten stage, oxygen and hydrogen elements and atoms, they will always get converted into gases. Let's say you have ferric oxide or ferrous hydroxide, which has molten inside. Now, the ferrous or the iron part of this oxide will get converted into liquid iron, the pure iron. But the oxygen part, that will not get converted into liquid, that will get converted into gas. So you had a situation, you had a circumstance where the outer part had solidified, but in the interior, the temperature, first of all, was very, very high. And along with that, you had also the presence of various gases. Now, these gases, they started exerting pressure on the surface. They wanted to emerge out of the surface. And at that point of time, the surface had recently solidified. So it was not as stiff and as solid as it is today. It was still very malleable and ductile, could be deformed very easily. So at that particular stage, when the cooling action had begun, you had multiple volcanic eruptions which occurred across the planet, which rocked the planet across. In fact, it is estimated that thousands and millions of such volcanic eruptions happened all across the planet during this stage. Now, why did so many volcanic eruptions happen? Because you had molten materials present in the interior and the crust was also very weak. But most importantly, you had enough amount of gases which could exert pressure on the surface to break the crust and come out. Now, this phase, when you had the phase of multiple volcanic eruptions, that modified the planet in a way that, first of all, it led to the release of immense amount of heat which was trapped. At the same time, you had huge amount of gases which was released. So you had oxygen and hydrogen which were released from the interior. Now this oxygen and hydrogen atoms, they combine with each other and they formed water vapor or H2O. So the gaseous form of water that was formed. You also had carbon dioxide, ammonia, methane, all these different gases which were released. Now, these gases were released into the atmosphere where the temperature was comparatively lower. So that is where condensation started happening and you had formation of a very thick layer of clouds. These clouds covered almost the entire planet, very thick layer. And also understand that these eruptions continued to happen, further enriching these clouds because more gases continued to be expelled. Now these clouds, they block the sunlight. And as they block the sunlight, it further accelerated the rate of cooling which was observed. So the cooling further increased. But then these clouds, they were so thick, so dense enough, and so continuous in their formation that these led to a phase where the planet is said to have received rainfall continuously for almost 7,000 to 10,000 years. Just imagine the scale of it. A continuous rainfall almost across the planet spanning for 7,000 to 10,000 years. This phase was referred to as the phase of torrential rainfall or endless rainfall. And it is this phase which filled up the depressions across the planet and you had water surrounding the planet. The whole planet actually ended up turning blue. And when you had so much amount of rainfall, the surface further cooled down. Now, till now we have seen that how the planet changed from the molten liquid form to a blue planet. Now, the phase when the gases were released in the form of volcanic eruptions, that is also referred to as the phase of degasification. So if you have to think about it, then basically you can talk about the planet evolving. First of all, you had the phase of collision, then you had the phase of degasification, then you had the phase of torrential rainfall, and you had the emergence of a blue planet somewhere around 3.5 billion years back. Now, the whole planet was covered almost entirely with water bodies, almost in every ocean. But underwater volcanic eruptions continued to happen because you still had enough amount of heat present inside. So these volcanic eruptions which continued to happen, they created newer islands and newer land masses which could emerge out of the water body, out of these larger oceans, and that is how the first land masses, they came into existence. Life came upon this planet almost around 50 to 60 million years after these events took place. And that is how the planet has been. Till now, the interior of the earth has got some amount of heat and a significant amount of heat which is retained since its time of formation. And that amount of heat is what is also referred to as residual. This residual heat, the name in itself will tell you that this is a residue which is generated since the time of its formation in itself. Now, in the initial few millions of years, hundreds of volcanic eruptions occurred on this fragile earth, the phase of degasification, causing materials from the molten magma coming to the surface along with gases, very vital gases. Now, these vital gases, they ensured cloud formation, they ensured rainfall, they ensured modification of the atmosphere as we know of it today, and also they were responsible for accelerated cooling of the planet, which further made the outer surface more rigid and more solidified. So this is how the planet has been formed. Now, once we have looked at the evolution and the formation of the planet, now let us take a look at the various different layers which make up this planet. So till now, we have already taken a look at the fact